Welcome to the nano world.
By using these amazing and interesting properties of nanoparticles, our scientist has discovered so many amazing things. But before watching this video, I would suggest you to watch my previous video on nanotechnology. The link of that video is in the description below. So let's start the journey to nano world.
When you try to make an electronic circuit, you need loads of crucial items to complete your circuit, and it needs a lot of time and high precision machines to complete the task.
So let's see what we can find in the nano world. A pen. What we can do with this pen?
Researchers at the University of Illinois has made a conductive ink from silver nanoparticles. They suspended the silver nanoparticles in a cellulose solution so that they can increase the viscosity and can flow from a pen. A line drawn by this pen on paper will become a silver wire that can carry a current enough to power a small LED light.
With the help of these nanoparticle ink, we can switch to the new era of paper electronics. Imagine how easy it would be to draw the circuit and wiring on papers and use it as an electric board.
But here comes the most important question: why they made the ink from nanoparticles? We know that electric current flows by movement of electron through a material. Materials used for creating electric circuit are generally made up of metals, because metals are usually good conductor of electricity. But to make a conductive ink, you need a liquid form of metal, while most metals are solid at room temperature. To deal with this challenge, the scientists have taken the help of nanotechnology. They dissolve the metal nanoparticles in liquid to make a conductive ink. This conductive ink usually contains two main components: metal nanoparticles, usually silver, and liquid part, generally cellulose, to carry the nanoparticles. These nanoparticles are tiny spheres of metal which are a few nanometers size. Each nanoparticle can conduct electricity, and when you draw a circuit using this ink on paper, electrons start traveling from one nanoparticle to the next. This is a modern day wastewater treatment plant. This system can help in removing the impurities from water. But can we do this complex task by using something which is of nano size? Chemist Edmiston with his team of researchers were searching for new ways to detect explosive at airports. But they have accidentally created something capable of absorbing oils and other organic liquids, but not the water, which leads to the creation of what's now known as Osorb. It's an organically modified silica or glass.
Due to the unique properties of this organically modified silica, we can produce clean water from pollutants.
Pollutants like oil, agriculture runoff, and other toxic liquids. Silica nanoparticles, being a porous materials, allow water molecules to pass but block other contaminants. Municipal water system and companies in several US states and Canada province are now using Osorb to address various contaminants including hydrocarbon, pharmaceuticals, pesticides, herbicides, chlorinated solvents, and many more. They have prepared these nanoparticles by adding some silica particles, acetone, and catalyst, and stirred them at a beaker for a few seconds. A firm gel is what they get as a product. This gel is what they have used to purify water from other liquid pollutants. We all know what makes plants such an important part of the environment. They absorb light and carbon and perform photosynthesis to release fresh oxygen into the atmosphere, which keep us alive. But the photosynthesis process itself is not very efficient.
These plants were only able to absorb 10% of the sunshine they receive, and the rest of the light they reflect back. Imagine if they were able to absorb more amount of light, what they can do.
A group of chemical engineers and biochemists at MIT is trying to answer this question by creating a super-powered bionic plant that can use photosynthesis to harness solar energy, detect airborne pollutants, and much more. By implanting carbon nanotubes in the chloroplast of the plants, researchers found that they were able to create an artificial antenna to help the plant capture wavelengths of light that normally don't absorb, including near-infrared and ultraviolet light. They inserted these carbon nanoparticles into the plant's leaf by simply injecting a solution to the underside of the leaves. The nanoparticles penetrate into the chloroplast, which is the photosynthesis site in the plants, within seconds without harming the leaves. Scientists found that the plants were able to capture about 30% more energy from the sunlight after the nanoparticle injection. When the plants were treated with carbon nanotubes that could detect the pollutants like nitric oxide and other molecules of the chemicals at extremely low concentration in air, the plants were transformed into living sensors.
If you like the series of Nano World, then hit the like button and show your love.
We will bring some more magic of nanotech in our next video.
Comment us down below the most common example of nanotech that we use in our daily lives.
If you are new to this channel, then don't forget to subscribe your own sci tech channel. See you in the next video.